Hello everyone, I welcome you all to this session. In this session, we are going to discuss the conflict serializability of given schedule. So let's first discuss what is conflict serializable schedule. I have already written here, schedule S will be considered as conflict serializable only if there exists at least one serial schedule as this. So if we can shift few of the operations in a particular schedule, or you can say non-conflicting operations, we can jumble up. And if we want to find out, or if you find out equivalent schedule to S, then we consider as schedule S is conflict serializable. Okay, so we'll understand this when we solve the problem in next slide. Two schedule S and S dash are conflict equal schedules only if S dash is resulted after swapping or exchanging some consecutive non-conflicting pairs, as I already told you. So if there are non-conflicting pair of instructions we swap, still the schedule will be equal, or the result of the schedule will be equal. Two operations in a schedule are said to be conflicting because we can only swap non-conflicting operations. So we need to understand what is the conflicting operations. So two operations will be considered as conflicting. There are three conditions if they belong to different transaction. The very first condition, they need to belong to different transaction. So let me highlight that. They need to belong to different transaction, right? Second is they need to access the same database or data set. Third one is at least one of the two operation is the right operation. So all these three conditions you should remember in order to consider the operations as conflicting. So if the operations are conflicting, we cannot swap them. Otherwise, we can swap. Okay, and I believe you understand the difference between schedule and transaction. Transaction is sequence of some operations like read, write operations, and schedule when the multiple transactions are going on in parallel. We consider that as schedule, right? So now let's solve the problems. Now the problems, like the very first problem, two transactions are given like T1 and T2 as follows, where when we write RIV, that means it is a read operation by transaction Ti on database V or dataset V. Similarly, when we write WIV, that means it is a write operation, and this write operation has been done by ith transaction Ti on dataset V. Okay, and here they are asking the total number of schedules that can be formed, T1 and T2 altogether. So total number of schedules, like the sequencing of read of write operation in this. So you can please remember the formula to calculate the total number of operations. So you can note down total number of schedules will be equal to the factorial of n1 plus n2 divided by factorial of n1 and factorial n2. What is this n1 and 2? Where n1, the number of instructions, the number of instructions in T1, and n2 is the number of instructions in T2. Okay, so here you can say n1 is given as 4, 1, 2, 3, 4, and n2 number of instructions in T2 1, 2, 3, and 4. So that means both are having 4 number of instructions. So when you put these values like n1 plus n2 will give you 8 divided by factorial 4, that means n1 factorial 4, the same number of instructions are in T2 also. Now when you solve this, you will get like this. You can solve 8 into 7 into 6 to 5, then factorial 4, and you can write 4 like 4, 3, 2, 1, and then factorial 4. You can cancel it out and you solve this like this. So you find out 7 5s are 35 cross 2, that is 70. So the total number of schedule, right? Total schedule, by considering the scenario where there are only two transactions, T1 and T2, and T1 is having 4 operations and T2 is having 4 operations. So in this scenario, the answer will be 70. But you can expand this formula for n number of transactions. So the total number of operations, by including, let's say there are n number of transactions, so n1 plus n2 till nn, and divided by factorial n1 factorial n2 factorial n3. So please note down it. Let's move on to the next question. Let Riz and Wiz denotes read and write operations on a data element Z by transaction Ti respectively, right? As we have discussed in the previous example also, S is given as this particular schedule is S. Which one of the following serial schedule is conflict equivalent to S? So in order to consider conflict equivalent, we need to look at the time sequence of this particular schedule. So let me draw that. So let's consider the situation in this. These numbers are reflecting transactions. So 4 means fourth transaction is doing read operation on this data set X. This second transaction is doing read operation on X. Third transaction is doing read operation on X, and so on, right? So the very first R4, that means fourth transaction is doing read operation. So that has been written here, right? So I'm highlighting like this. Next read operation is being done by transaction 2. So I have written here. Then third transaction is doing read operation after that. So this is here. In that sequence I'm writing. Then first transaction is doing this read operation on Y. Then first transaction is doing write operation on Y. Then second transaction is doing read operation on write operation on X. This is. And then third transaction is doing write operation on Y. And finally, fourth transaction is doing read operation on Y. So I hope you'll be able to understand the sequence. Now what they are asking is which one of the following serial schedule is conflict equivalent to S? So which is conflict equivalent to S? You just need to prepare a kind of sequence diagram of these transactions. So let's consider, let's say there is transaction T1, T2, let's say T3 and T4. Now we need to decide the sequencing in that based on the available conflicting operations. Conflicting operations are, there can be basically three types of conflict: read write conflict, write read conflict, write write conflict. Okay, so let's check. The very first thing, focus on this read X. Read X will be conflicted with write X. And we need to check in another transaction. So let's say this T4 is reading on X. Then we check T3, T2 and T1. We do not check in the same transaction, right? So read X, you check in T3. T3 is having only read X. Read, there's no conflict. So there's no conflict with T4 and T3 in terms of X. Then if you check T2, T2 is performing write X. So there's a conflict between read X and write X. So we need to draw an arrow from T4 to T2. So we can draw an arrow from T4 to T2 like this. Okay. Now check T1. So T4 is reading X and T1 doesn't perform any operation on X. So that's it. Now let's consider next. Next is read X by T2. Now we need to check the conflict of this read X with any of the write X in rest of the three transactions. So let's check in T1. In T1 there is no operation on X. Let's check T3. In T3 there is no write operation on X. Let's check T4, there is no write operation. So no conflict of this. Now check this one. Read X in T3 will be having conflict with write X. So let's check T4. T4 doesn't have any write X. T2 have write X. So T3 to T2. T3 to T2 there will be an edge. Okay, T3 to T2. And check T1. T1 doesn't have any operation on X. So let's consider this next read Y in T1. Read Y will be conflicted with write Y. Okay. So let's check T2. There is no write on Y. T3 there is a write in Y. So there is a conflict like T1 to T3. T1 to T3. T1 to T3. Like this. Okay. Now check in T4 also. So read Y and there is read Y only. So there is no conflict. Now let's check this write Y in T1. This write Y can be conflicted with read Y or write Y. So check read or write operation in T2. There is no read or write operation on Y. No conflict. In T3 there is a write operation. So T1 to T3 there will be an arrow. T1 to T3. T1 to T3 already there is an arrow. And read Y will be conflicted with write Y. So T1 to T4 there will be an arrow. T1 to T4. Sorry. Then check this one. This write X will be conflicted with either write Y or read X. So there is no read or write X here. There is no read or write X here. Similarly for this, check this write Y. Write Y will be conflicted with this read Y. So there will be an arrow from T3 to T4. T3 to T4. There will be an arrow like this. Okay. Now based on this, if we want to execute it and we want to decide whether it is conflict serializable or not, we need to find out, is there any cycle in this? There is no cycle in this. That means the schedule is conflict serializable. Okay. Now if this schedule is conflict serializable, in which order these transactions will be completed? It is being asked in this. So we can easily find out, because T1 doesn't have any dependency. T1 is having only outgoing edges. So very first thing, T1 can be executed, right? Because other nodes are having incoming edges also. T2 is having incoming edges. T4 is having incoming edges. T1 is also having incoming edges. Incoming edges means dependency of the sequence. So that means the very first T1 need to be executed. That means C and D are wrong. Now once you finish this T1, so let's say I have finished it. So these arrow also I am considering cancelled out. Now you consider if these two arrows are cancelled out, T3 will not be having any incoming edges. So after T1, T3 can be executed. So that means A will be the right one, B is also wrong, right? Let's move on to the next question. There are two schedules are given, S1 and S2. Which one of the following operation is correct? S1 is conflict serializable, so we need to check in the same fashion which we have done in the previous. So let's draw. Okay, so this is S1 and this is, let's say, S2 schedule given over the transactions T1 and T2. So the sequence is given. Very first operation is read operation on X by transaction T1. So I have written here read operation on X by transaction T1. Then the next is read operation on Y. So read operation on Y. Read operation on X by T2 transaction. Read operation on Y by T2. And then write operation on Y by T2. And write operation on X by T1. Similarly, this S2 schedule you can write like this. First read operation on X by T1, read operation on X by T2, read operation on Y by T2, write operation on Y, write operation on Y. So this is write operation on Y, not X, this is Y, right? By T1, T2, and then read operation on Y by T1 and write operation on X by T1. Okay. Now to decide the conflict serializability, we need to draw the graph. So let's draw the graph for S1. So we consider T1 as well as T2 here and try to decide the dependency. So R1, we find out the conflicting pair. R1, Rx means read on X will be conflicted by write X. There is no write X in T2. Read Y, write Y. So there is a conflict. So there will be an arrow from T1 to T2. Now you check this read X, and there's a write X. So there's a conflict from T2 to T1. Now I told you in the previous question, if there is a cycle in this dependency graph, then you can say this is not a conflict serializable. So that means S1, because this we have drawn for S1, S1 is not conflict serializable. Okay. So wherever S1 is conflict serializable is written, it will be wrong. Now let's check for S2. So for S2 you draw T1 and let's say T2. Now read X will be conflicted by write X, so there is no write X in T2. This read X will be conflicted by write X, so T2 to T1 there will be an arrow, T2 to T1, T2 to T1 there will be an arrow. So let's draw like this. Okay. Then read Y will be conflicted with write Y, but there is no write Y. This write Y will having the conflict will even read, so T2 to T1 we have already drawn, and there is nothing left. So this is the scenario. Now there is no cycle in this. There is no cycle in S2, but there is a cycle in S1. So S1 is not serializable, not conflict serializable, but S2 is. So the answer would be S1 is not conflict serializable and S2 is conflict serializable. The B will be the right answer. Let's solve the next question. Consider a schedule of transactions T1 and T2, and the schedule is given like this. Read operation on A by T1, then read operation on B by T2, write operation on B by T2, read operation on C by T1, read operation on D by T2, write operation on D by T1, and so on. And finally commit and commit. Now here Rx stands, you know that which one of the following schedule is conflict equivalent to the above schedule. Conflict equivalent. The equivalency of two schedule depends on the order of operation which is being performed. So if you compare, like the very first read operation on A in this schedule is being performed by T1. Okay. So whatever these four options are given, we need to check. The very first read operation on A must be done by T1. So read operation on A, the first operation on A must be done by T1. Then only we can say, right, it can be equivalent. And the final write operation on B will be done, is being done by T1. So write operation, final write operation on B is being done by T1. Like if I compare the read operation on A, the first read on A is being done by T1 only because T2 is not reading A, right? So it is okay. Then first read operation on B is being done by T2. So first read operation on B is being done by T2, right? And the very first write operation on B is being done by T2. So here it is fine because T1 has not done the write operation yet. So this is fine. Then the very first read operation on C is being done by T1. So the read operation, the first read is here only. Okay. So this is also fine because T2 not yet read C. Then first read operation on D is done by T2. So that is also fine. Then the first write operation on D is done by T2. So that is also fine. Then the write operation on C, and it is the first write on C done by T2. So write operation on C done by T2, right? And write operation on B is done by T1. So final write on B is being done by T1 and final write on C is being done by T2. The rest of the sequences are fine. So the answer will be A. The answer will be A for this. The rest of the options are wrong. So if you want to check them, you can check like this. A read operation on A, the very first operation on A as a read need to be done by T1. So that is fine. It is okay. It is okay. Then read operation on C, the very first read should be done by T1. So the very first read is being done by T1. It's not a problem. The write operation on D is being done after read operation on D. So T2 is reading D, then T1 is writing D. But here T2 start writing on D, but T1 has not read, so it is reading after writing. It is wrong. So this is not the equivalent schedule. In this you can check reading operation is being done by T1, that's fine. Reading operation on C, first thing is being done by T1, that is fine because in this the original schedule also the read operation on C was done by T1 only. The write operation on D, T1 is doing, but again the same thing. Before write operation, T2 was reading, so this is a problem. This is a problem. Then in this read operation is being done by A on T1, that's okay. Read operation on C and write operation on C has been swapped. So in this schedule, read operation on C was done by T1 first, then the write operation on C. But here there is a problem. So this is also a wrong answer. I hope you get the idea. Let's move on to the next question. Which of the following schedule are conflict serializable? So again you check, it is very easy. And the number like R2, R1, R3. So there are three transactions, right? So let me draw the sequence. Okay, so this schedule I have drawn for S1, and this representation is for S2 schedule. So you can verify that how I have written this. Read operation on A by transaction 2, so I have written in this particular column in T2. Then after read operation by T1 on C, then read operation on B by T2, then write operation on B by T2, then read operation on B by T3, then read operation on A by T1, then read operation on C by T3, write operation on C by T3, and then write operation on A by T1. Similarly, I have written this thing, read operation on A. So let me highlight, read operation on A, the very first operation by T2, then read operation on C by T1, read operation on B by T2, write operation on B by T2, read operation on A by T1, read operation on C by T3, read operation on C by T3, write operation, and the write operation on A, right? So the same thing we need to do is draw the diagram. So let's say you are having T1, T2 and T3, three transactions. Check for first schedule. Our read operation on A will be conflicted on if we perform write operation on A. So if you check the conflict of this operation in T1, there is a write operation on A. So T2 to T1, T2 to T1, there should be an error. Okay. Then you check this read operation on C. You check in T2, there is no operation on C. Then T3, there is a write operation. So T1 to T3, T1 to T3, there should be an arrow because there is a conflict. Then you check for this read operation on B. There is no operation on B in T1, and there is a read operation on B, so there is no conflict. Read, no conflict. Write, read, there will be conflict. So T2 to T3, there will be an arrow. T2 to T3. Okay. And if you check here, there is no operation on B. So this read B will not be conflict any further. Read A will not be conflict here. So there is no further conflicts. That means there is no cycle in this, and this is a serializable schedule, conflict serializable. Now if you draw, this is for S1. So I write in the middle S1. Now if you draw again for S2, like T1, T2 and T3. So check it. This R will be conflicted by write A. So write A is not here, write A is here. T2 to T1, there will be an arrow. Then for this read C will be conflicted by write C. So T1 to T3, there will be an arrow like this. Then read B, there is no conflict in T1 and T3. Write B, there is no conflict in T1 and T3. Read A, there is no conflict in T2 and T3. Write C, there is no conflict. Write C, read C, no conflict. Write C, and there is read A, no conflict. So that means it is also serializable. So both are serializable. The answer will be S1 and S2 both are conflict serializable. Let's solve the next question. Consider the following schedule. R1, this, given like this. The above schedule is serializable as. You need to find out the sequence. So let's do it quick. Right. So the given schedule can be written like this in a sequence. This read operation by T1 transaction on X, then read operation by T2 transaction on X, then read operation on Y by T3 transaction, then read write operation on X by T2, read operation on Z by T4, read operation on 3 on Y by T3, then read operation on Y by T1, then read operation on Y by T2, write operation by T1 on Z and write operation on X by T4. Now let's check the serializability. So we draw T1, T2, let's say T3 and T4. So check the conflict of this read operation, right? Yes. So T1 to T2, T1 to T2, there should be an arrow like this. Then in T3, no operation on X. Then T4, there is a conflict T1 to T4, read write conflict. So T1 to T4, there need to be an arrow like this. Okay. Then you check for this read, there is no conflict in T1. Read X, there is no conflict here, but there is a conflict T2 to T4. So T2 to T4, there is a conflict like this. Then check for this read Y. Read Y will have conflict with write Y. So there is no conflict in T2. There is no conflict in T1. There is no conflict in T4. Check for write X. Write X will have conflict with read or write X. So there is no conflict in T1. There is no conflict in T3. There is a conflict in T4. So T2 to T4, it is already drawn. Then this read Z will have the conflict with write Z. There is no conflict in T1 or T2, but there is a conflict in T1. So T4 to T1, read write conflict, T4 to T1. And when you are drawing T4 to T1, that means there is a cycle. So once the cycle comes, then you can say it is not serializable. The answer will be D. Right? So this is sufficient for this session. Thank you for connecting. See you in the next session.